Okay, function notation looks like this. Okay, but it doesn't always have to be f. So the difference is normally we see y equals 2x plus 1, but now we have this, right? That's how we know it's function notation. But it could also be like this, or really any letter in front. Now those are the three most common letters, but really it can be any letter, okay? And the way we read that is f of x. So f of x equals 2x plus 1. You would read this g of x, and so on and so forth, right? Okay, and what does it mean? So it's telling you it is a function. That's why we call it function notation. Also, f of x equals y. Any questions with those things? Okay, so all of these things can be done in the calculator. However, I'm also going to show you how to do them mathematically. I'm only ever going to do one mathematically, and I'll show you how to do the rest in the calculator, yes? Okay, so the first one, if we were to do it mathematically, well, I want you to realize it's f of negative 2. Well, what normally goes inside those parentheses? That x, right? So if I don't have an x, I have a negative 2. What is that telling me x equals? Yeah, so we know x equals negative 2. It has an f in front, so we're talking about the f equation. So that's this one. So we have 3x squared minus 5. Well, instead of x, what am I going to plug in? Negative 2. So 3 times negative 2 squared minus 5. And I say by hand or mathematically, but really all you have to do is plug it in, and then what do? Type it in your calculator. So 3 times negative 2 squared minus 5. And what does that equal? 7. So we have f of negative 2 equals 7. Now, I want you to realize you can also write that as a point, because inside your x and outside your y. So this is the point negative 2, 7 is on that line. Does that make sense? Okay.
Is less than bigger? The smaller one than the bigger one?
No, it's x comma y. Yeah, because x is on the inside of your parentheses, right? Look right here. F of x equals y. So this is f of x equals y, x, y. Okay, so the next one says g of negative 3, so now I'm going to show you in the calculator. Okay, so in my calculator, I'm going to come here and I'm going to type the g equation up top. Well, that is this one, g of x, so 4x plus 1. So I pick the g equation, I'm typing it in. And I'm going to go to my table. Okay, and I need x to equal what? 3. So I know x equals 3 when we're trying to find y. Well, when x is 3, what does y equal? 13. There you go. Pretty simple, yes? Okay, so we're going to do another one. Now I can write this as the point 3 comma 13. Now this next one, I already have the g equation in my calculator, right? So I have an f, a g, and an m. So I'm going to go ahead and do this g2, g of 2. So if you come here to 2, what does it equal? 9. So I know on the bottom of this fraction it's going to be 9. Are we okay with that? Okay. So knowing that, I'm going to go ahead now and type in my f equation. And I have 3x squared minus 5. I'm going to check my work here first. Well, if I have x was negative 2, did it equal positive 7 like we said it would? Yeah, it does. So we did it correct. Now if I come here and I have f of positive 2, what does that also equal?
7.
7. So the top would be 7. Now, does 7 over 9 simplify? No, 7 is prime and 7 doesn't go into 9, so it does not simplify. Now, you cannot write this one as a point because this has multiple functions. So that's your answer. Okay, so now let's look at the last one with function m. So we have the equation negative 3x plus 5 for m. And I'm going to show you how to do this one in the calculator because it can be different. So I'm going to go to my table, and I'm looking, does it have fractions? No, so you can hit second window. So second window, and see how it says table start? You can type whatever you want. Well, can I type 2 over 3 as a division, like that? Yeah, and I could hit second graph, and what does it equal? 3. So this does give me the point 2/3, comma 3. Yeah, you could do it the other way like we did on this one. That's totally fine. That's why I'm showing you both. Whichever way you prefer, I'm happy with. Yes? But I'm going to show you both every time. Now, if you ever want to go back, just hit second window again, and you can type 0 or 1 or whatever, and it'll go back to normal. Okay? Any questions with those? Okay, I'm going to take attendance. I want y'all to try to find the mistake on this one. Did anybody find the mistake? This? Yeah, so if you square a negative, what happens? What's a negative times a negative?
Positive.
A positive. So if you were to simplify this to become this, shouldn't it be positive 1 over 16? So that is where our mistake is. Any questions with that? Okay, now let's look at the graph. So when given a graph, I'm going to bold the lines to make it a little easier. Okay, this is my x-axis. This is my y-axis. And then this is my graph. I know it's a little crazy. Okay, so knowing that, we're going to figure this out. So I know that this is x equals negative 2. So I'm going to go on my x-axis to the negative 2, and I need to find the height of my line. Well, what is the height of my line at negative 2? 4. So that is the point negative 2 comma 4, which is a solution. Okay, what about if I go over a positive half? Well, did that even go up or down? So what number does that represent? 0. So this is the 1/2 comma 0. And then lastly, I have over 2, 1, 2, and I went down just a little bit, so what would that be?
How did you go down?
Because I went over 2 and my green line is down.
You don't start at the point that's it.
Huh?
You don't start like after 2.
Well, here is the 2. The line's not there. So I do go down and it's negative 1. I feel like the most mistakes happen when we have a 0, either as my x or my y, so be careful when there's zeros, yes? Okay. Now look at this one, example 4. It says, given all of these points, find g of 3. Well, which point has x equals 3?
32.
This one, right? This is my x, so what does y equal?
2.
So g of 3 equals 2. Okay, now on this one it says, suppose that y equals f of x, and it is true that f of negative 5 equals negative 33. Well, freeze. My x is negative 5 and my y is negative 33, so I know that this is the point it's talking about, right? It says determine whether it is true or false that it is a possible function for this one. So I need to plug it in and see if it's true or false, is all it's saying. So y is negative 33 equals 7 times x is negative 5 minus 2. All I've done is plug it in. Yes? And then I'm going to say, see what it equals. So negative 33 equals 7 parentheses negative 5 parentheses minus 2. And it equals negative 37. Does negative 33 equal negative 37? No, so this is false. Any questions with that? Okay, when you're done writing that down, go ahead and flip to the back. Okay, so it says the table gives annual net sales in billions of dollars for Target stores for the years shown. So it says write the paired data as a set of ordered pairs. Well, a set of ordered pairs is x comma y, correct? And my table, this is my x and this is my y. So I have 2009 comma 65. I have 2010 comma 67. 2011 comma 70, 2012 comma 73, 2013 comma 73, and 2014 comma 73. So there's my set of ordered pairs. Now if we want to be real proper, you would write it in fancy brackets with commas in between, kind of like we do when I'm asking you questions. Now the next one says to graph that paired data that we just wrote down. So we have to set up our graph first. And I want you to realize this is my x-axis. This is my y-axis, so x is years, and y is my net sales. Have y'all ever seen those graphs where they have like the squiggle between, like the zigzag between the 0 and the first hash mark? So they do that when they jump from like 0 to 2009. Do you really want to start at 0? No, not when we're starting at 2009 as our smallest number. So when you put that zigzag, you're saying you skipped all of the portion between 0 and 2009. Does that make sense? Now, if you don't put that zigzag, I'm not going to count off, but I want you to understand that's what proves that. So I'm going to make sure I go 2009 to 2014. So 2009, 10, 11, 12, 13, 14. I can count by ones and still have space, right? So I have 2009, 2010, 2011, 2012, 2013, 2014, and that's as far as my data goes. Now my data also goes from 65 to 73. So again, we don't want to start at 0, so we have our zigzag. and it goes 65, 66, 67, 68, 69, 70, 71, 72, 73. So I can fit all of my numbers in there. Okay, so I have 65, 66, 67, 68, 69, 70, 71, 72, 73. And now we just plot our points. So that was the hardest part, in my opinion. Once you have that part done, plotting your points is super simple. So 2009 was 65. 2010 was 67. 2011 was 70. 2012 was 73. 2013 was 73. And 2014 was 73. Now, what trend in the paired data does the scatter diagram show? What's happening? If you look at all the dots, what's happening? It's going up. What's another word for that? It's increasing. Now, what if we were only looking at these 3 points? Would we still say increasing?
No.
No, what would we say? Really, it's staying the same, right? There's no change. But since we're looking at all the points, the data is increasing. Yes? Any questions with that? Okay. So let's look at the other ones. These are kind of a little mixed up practice of different things. Okay, so this one says determine whether each ordered pair is a solution of the equation x minus 2y equals 6. So again, I told you I'm going to show you all 2 different ways. I'm going to show you all mathematically, and then I'm going to show you calculator. Yes? Okay, you have to do math to type this in the calculator, but it's still solving once versus solving 3 times. So the first one I'm going to do mathematically. So I'm going to write my equation x minus 2y equals 6, and I'm going to plug in my x and my y. If it's a solution to this equation, then it's going to make a true statement, correct? Yes. So 6 is my x, minus 2 times 0 is my y, equals 6. Well, if I type that in my calculator, 6 minus 2 times 0, does that equal 6? Yes. So 6 equals 6. Therefore, yes, this is a solution. Okay, because when I typed it in my calculator, it gave me 6. Are we okay with that? Okay, now I'm going to show you calculator. First, you have to solve for y. So when you're solving standard form, this is standard form. We're going to talk about it more in our, later in the unit. Okay, you have to get y alone. So first things first, you're going to move the x. So minus x, and these x's cancel. And I get negative 2y equals 6 minus x. Is my y alone yet? Not quite. What do I still need to get rid of? The negative 2. So I'm going to divide everything by negative 2. Now I have y alone equals 6 divided by negative 2 is negative 3. And I want you to realize there's technically a 1 in front of this x. And 2 negatives makes a. So this becomes 1/2 x. Technically, if you typed in your calculator as x over 2, that would be fine too. And now you can literally just type that in your y equals. So I have negative 3 plus 1/2 x. Are we okay with that? So I solved for y, I typed it in my calculator. Now I'm going to go to my table and look at my points. Do I have the point 0, positive 3? So is this a solution? Let's check our work on the first one. Do I have the point 6, 0? Yeah, so I did the first one correctly. And then let's look at the last one. It's 1, negative 5 over 2. Well, look, do I have positive 1, negative 5 over 2? So then this is a solution. Does that make sense? So you can solve once and type it in your calculator, or you can solve 3 times, but simpler. It's up to you. Okay, so let's do another one kind of similar. I'm actually going to do number 3B in the, by hand. No, you know what? Actually, we'll do C. So I want you to notice that this one gives me X, but it doesn't give me Y. Therefore, I don't know Y. So I'm going to plug in X and solve for Y. So I have 3 times negative 1 plus Y equals 12. What's 3 times negative 1? Negative 3. And now how do I move that negative 3 to get Y alone? No. There's a plus sign in the middle. So it's not multiplying, it's adding. So what's the opposite of negative 3? And I get Y equals 15. So that's how you would do them one at a time. Or you can solve for Y. Now this one's a simpler solve for Y. So you're going to move the X, divide by what's in front of Y. That's the same thing every time. So if I move this X, I'm going to do minus 3X minus 3X. And these 3X cancel, and I get positive Y equals 12 minus 3X. Well, is Y alone? So was that a super simple one to solve for? Yeah, so this is an easy calculator problem. So I have 12 minus 3, not times, dang it, 3X. And I'm going to go to my table. So we can check the point. Did negative 1 positive 15? Did we do it right? Yes. Now here, what did it give me, X or Y? Y. It's telling me Y is 6. So we're going to look in the Y column here. 6. What does X equal? So this is 2. And then here we have the X is 0. What's Y? Oop. 12. So pretty simple in the calculator, yes? Now it's not hard to do like this either, so I really don't mind whichever method you do. Number 4, is this one already solved for Y? So type it in your calculator. Don't make your life hard. Alpha Y equals, enter 1 over 2 X minus 5. Second graph, so I'm looking for where X is negative 2. What did it give me? Then it gives me 0, and what's X? Oh, what's Y? And then it gives me Y is 0. So I'm going to go over to the Y column, and I want you to realize the numbers are getting closer to 0 down, so I'm going to go down. And there's 0. What is X? 10.
Why is it not just
On negative 2? Because a half of negative 2 is negative 1, right? And negative 1 minus 5. If I take 1 and I take 5 more, it's negative 6. Yeah. Okay, this last one is, it's like a word problem, but it's not. Y'all, we're not going to really do it. If I give you the equation, I tell you to fill in the table, don't you just do kind of what we did there? Yeah, so let's not overthink that. Okay, I am going to let you on the practice cross off number 7 and number 8, just because those are super time consuming and it's like the same thing over and over again. So I left number 9, so you're still practicing it, but that way you have plenty of time to get it done today in class.